Boys and girls, this is Mr. Manise here again with a super cool video, and in this video I'm going to walk you through how to solve each of the problems on the test review for our coordinate geometry unit. Boys and girls, this test is hard. It is difficult. One of the reasons why it's difficult, there's several reasons. One reason is because it's not multiple choice. One reason is because it's just difficult in itself. I think this is the only test of the whole year. I think we might have two that are not multiple choice, and this is one of them. The material itself is just difficult, and also we have spring breaks sandwiched in between on the front and front end of the unit, the back end of the unit. So some of the stuff you guys haven't seen in a few weeks. And one of the reasons why grades are notoriously not as high as we would like on this test is because of time, okay? You guys are going to have to be as prepared as you've been all year long. You got to be able to walk in and immediately know how to complete the square on a circle, immediately know how to figure out what the equation is from a quadratic table. Okay, you can't spend 10 minutes, oh my goodness, I can't really remember how to do that. You cannot afford to do that. So you really need to buckle down, work your rear end off to make sure when you walk into the class that you are fully equipped and ready to go. If I were you guys, I would be walking around school with my test review. I'd be studying it on the bus, studying in the morning, obviously study really hard the night before. I'd be studying it at lunch. If your test is after lunch, I'd be doing everything I can to make sure that all this information is saturated into my brain when I walk through the door of my math classroom. Okay. So for my Clemson reference today, I have my lovely purple and Clemson shirt here. I know it's upside down, but beautiful little lifelong symbol there. That's all I got for today for the Clemson reference. So let's just jump right in here. All right, so a lot of this stuff, of course, is on the videos that I've made prior on quiz review videos and that kind of thing. So I may go a little bit faster than normal. This is a kind of a long test review, and so I'm going to kind of skim through some of the stuff that you should already know. The first one here, identify the indicated formation on each circle or parabola and then graph it on the coordinate plane. This is super easy right here. We've got a circle. How do I know that? Because I've got two sets of parentheses squareds. I have this is my r squared. So if you guys remember, your formula is for a circle is x minus h squared plus y minus k squared equals r squared. Okay. All I have to do here to get my center is flip these two signs. I'm always flipping the signs of the guys inside the parentheses squared piece. All right, so flip that. So that's just going to be 3 comma 2. R squared is 25, so if I take the square root of 25, my radius will be 5. Okay, that needs to be one where you walk in the door and just bam, you just knock it out immediately. To graph it, of course, I'm going to come over here to my grid, plot right 3 up 2, and I just need 4 points, up, down, left, right. I'm going to count 5 in every direction. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Guys, this does not have to be an absolute perfect circle. Just give me a rough drawing. Just give me a rough sketch. 1, 2, 3, 4, 5. I plotted the wrong point there. I looked a little bit weird. Okay, just give me a rough sketch of the circle. That's good enough. All right, number 2. This is a parabola. How do I know that? I only have one set of parentheses. I only have one parentheses squared piece. All right, so for the vertex, always remember, what do we do with that sign of the guy in the parentheses squared? We flip it. So the vertex is -1. All right, this is my h, and this is my k. I don't flip the sign of the -6 because it's not in the parentheses squared piece. So my vertex is -1, -6. For my transformations, there are actually a couple of typos on this original test review, guys. I went ahead and corrected those before I made this video, so your sheet might look a little bit different than mine on a couple of these problems. This one actually does have the 4 blanks for the 4 transformations. First thing I look at is, do I have a negative sign in the front? Yes, I do. So when I have a negative sign, I'm always going to have a reflection, and it's always going to be reflecting around the line y equals, and it's always going to be whatever this k value is. Okay, so if the k value is -6, I'm reflecting around the line y equals -6. Okay, so there's my reflection. Yes, I have a negative. No, I don't have a negative. Next thing I look at is this a value. Okay, the a value is 2/3. Okay, that's less than 1. When it's less than 1, I am compressing my quadratic. I'm sitting on it. I'm squeezing it. It's getting wider and fatter. Okay, so I'm going to have a vertical compression by 2/3. Well, what if this number had been higher than 1? What if this had been a 3 or a 4? Then that would be a stretch by 4, a stretch by 3. Again, guys, the negative has nothing to do with the stretch or compression. The negative just means it flips. It just means I'm reflecting. So the negative, don't even just cover up the negative when you're looking at the A value. 2/3 is a fraction, that's compression. If it's greater than 1, that's a stretch. The parentheses is your horizontal translation. I'm moving left to right. Now, you would think this is right 1, but remember, my equation is y equals a times x minus h squared plus k. We're subtracting h, so it's backwards, okay? So even though you would think it's right 1, it's actually going to be left 1. The k is your vertical translation, shifting up or down. Since it's negative, we're going to be going down 6. All right, so to plot this, how do we plot this? Well, I need to first of all plot my vertex, -1, -6. That's down here. Now I need my trusty calculator. Here's where we have to use our calculator to get us a little x and y t-table. So I'm going to go to y equals, and I'm simply going to type in my original equation. So -2 divided by 3 parentheses x plus 1 squared minus 6. Let's just graph it just to see what it looks like first. Okay, it's on the grid. That's good. So now I need a table of values. So I go second table. All right, so I like to write down my vertex first in the table. I'll get them about halfway. I like to just kind of put a rectangle around it and say V, that's my vertex. So on my calculator, I need to scroll till I see 1, -6, there it is. Then I need 2 points above it and 2 points below it. So I have a -2. Now this is a -6.7. That's okay. We can plot decimals. I think we are capable of doing that. I'm pretty sure we can do that. -8.7. 0, -6.7, and 1, -8.7. Okay, don't let decimals scare you. Yeah, guess what, guys? Not everything in life is going to be nice, pretty, round, whole numbers. You know, sometimes you got to go between the lines. All right, so let's plot -1, -6. I got -2, -6.7. Well, there's 6, there's 7. I'm a little bit less than 7. Okay, a little bit less than 7. I have -3. -8.7. Well, there's -8, there's -9, so it's a little bit less than -9. On the other side, it's going to be perfectly symmetrical. And again, this doesn't have to be perfect, guys. All right, and there's my plot of my parabola. It's opening down. Why is that? Because we have a reflection. Guess which line it's reflecting around? It's reflecting around this line, y equals -6, which was our k value up here. Okay. All right. Circle. All right. How do I know it's a circle? I've got a x squared and a y squared. Okay. When I have two sets of things squared, I'm in circle land. All right. So how do I get this into standard form? We have to complete the square. Okay. So how do I do that? First thing you got to do is make sure the constant is moved to the other side. So let's get this guy over here. So we're going to subtract 4 from both sides. Now I'm going to pair up my x terms and my y terms and complete the square on both. So I'm going to have an x squared, where's my other x? Right there. Plus 4x. Now here's where I'm going to complete the square. So I'll do plus blank in orange. I'm using these random purple and orange colors. Alright, and now I'm going to pair up the y's. So I got plus y squared. Where's my other y term? There it is, minus 4y. Then I'm going to have another plus blank. Alright, then I got my equal sign, and then I'm going to have the -4, the constant that we moved to the other side, and then I'm going to have 2 more blanks. So plus blank, plus blank. Remember with the circles, we got 2 blanks on the left, we got 2 blanks on the right. So whatever numbers we put in these blanks on the left, we got to put those same numbers in the blanks on the right. Alright, so now how do we actually complete the square? Okay, so I'm not going, guys, we've done this enough. I mean, by now you should really know how to complete the square. Okay, so how do we complete the square? We take half of b squared. Half of 4 is 2. 2 squared is 4. So if 4 goes in that blank, half of -4 is -2. -2 squared is also 4. So 4 goes in that blank. So if we have 2 4s in those 2 blanks, I'm going to have 2 4s in these 2 blanks. Okay. All right, so now why do we do all that? We completed the square so that now I could factor this perfect square trinomial. How does it factor? Half of the b term. Half of 4 is 2, so it's x plus 2 squared. Half of negative 4 is negative 2, so yes, this must be a y minus 2 squared. Okay. On the right hand side, I just combine my like terms. Negative 4 minus 4, negative 4 plus 4 just cancel each other out, then plus 4. So I'm going to have equals 4. Get my camera to refocus. Okay. All right. So if you're still struggling with how to complete the square, we've got plenty of notes. I've got plenty of videos on this. You just need to go back, come in for tutoring or whatever you need to do. Let me help you so you can make sure you're comfortable with completing the square. All right, so this is my standard form. I'm just going to draw an arrow over here. So that's what goes in that blank. All right, for my center, I flip the signs. Negative, positive. So my center is negative 2, 2. And my radius, remember this is r squared. I don't want r squared, I want r. Square root of 4 is 2, so my radius is 2. All right, so now I'm ready to plot this. I go to my center, negative 2, 2. And my radius is 2. So I just go 2 in every direction. And sketch a little circle there. There we go. All right. That's completing the square twice on circles. All right, so now for the one down here at the bottom, now I'm going to complete the square. This is a quadratic because I only have one x squared. And it says vertex. If I see center, that's circles. If I see vertex, that's parabola. All right, so to get this in vertex form, I got to complete the square. I know it says f of x, but that's the same thing as y. Y equals x squared plus 8x plus 21. All right, so remember, now here I'm going to complete the square. I'm only going to complete the square on these two terms. I'm going to leave the 21 outside, okay? So I'm going to have y equals x squared plus 8x, and then here comes my blank, plus blank. All right, and then I'm going to have the 21, and then I'm going to have another blank. Okay? All right, so how do we complete the square? Okay, so half of b squared, get my green here, half of b squared, half of 8 is 4, 4 squared is 16, so 16 goes in that blank, but now since both of my blanks are on the same side of the equation, I've got to offset this 16 with a negative 16, because these guys have to cancel each other out to get back to my original equation. Alright, now the whole purpose of doing that is so now I can factor this perfect square trinomial. It factors as half of b, half of 8 is 4. So that's just going to be x plus 4 squared, and then I combine the 21 and the negative 16, that's plus 5. So that is my vertex form. Y equals x plus 4 squared plus 5. Your vertex, flip that sign, leave that sign alone. So that's going to be negative 4 comma 5. And the transformations, I don't have a reflection, I don't have a stretch or compression. This is my horizontal shift, it's plus 4, so that means we're going left 4. It's backwards, and then that's your vertical translation, so we're going up 5. Okay, alright, so we need to plot this. So my vertex is negative 4, 5. Alright, so once again I need my table of values. So I can either type in the vertex form or the original, guys. They're the exact same thing. That's the whole point of converting one from the other. I'll just plug in the original quadratic equation, x squared plus 8x plus 21. And let's go second table, and let's get some values. All right, so my vertex is negative 4, 5. So let's scroll to negative 4, 5. Vertex. And 2 points above it, and 2 points below it. Okay, let's go ahead and plot this. Okay, so we've got negative 5, 6. we have -6, 9, -3, 6, and -2, 9. Okay, and there is our graph. Okay, let's flip on over to the next page. EQ, of course, just means equation. It says write the equation in standard form of the circle or parabola given the information. You might want to draw a sketch first. So you don't have to sketch in these if you don't want to. It just might help you, okay? We've got a circle with a radius of 6 and a center of -3, 0. So here again is my equation of a circle. Okay, so when I go from center to equation or equation to center, I've got to flip both of these signs. All right, so if I flip that sign, that's going to become x plus 3 squared plus y, this is my h and my k, y minus 0. Okay, well, what is y minus 0? It's just y. So actually, I'm going to go ahead and erase this. So y minus 0 squared is just y squared. And then I'm on r squared. If my radius is 6, I got to square that, so that's going to be equal to 36. All right, so if I graph that, my center is -3, 0, and I'm going up, down, left, right, 6 in all directions. Up to 6, down to 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And let's draw a circle. Right. Next one. This is one of the hard ones, guys. This is one of our ones on the first quiz where you had to find the equation given the endpoints of a diameter. Okay, so normally with our circles we need two things. We need what? We need the center and we need the radius. This one was easy because they gave us both of these. This one's not easy because we don't have either of them. We've got to use some formulas to figure out what both the center and the radius are. Okay, so if I come out here and just kind of draw myself a little sketch, two endpoints of the diameter. All right, so there is my diameter. Okay, so if I'll go ahead and plot these 2 points, 2, 7 and -4, 1, there are 2 endpoints on the circle. Okay, so if I connect that line, that becomes my diameter. Okay, now I need to find this length so that I can find the radius. Well, you can do that one of two ways. You can either use the distance formula, which on the quizzes that I graded in this unit, every time a student made a mistake finding a distance, every time that student used the distance formula. The students who used Pythagorean Theorem hardly ever made a mistake. Why? Because number one, Pythagorean Theorem is easier and it's quicker, but number two, you don't have to deal with any negatives. In the distance formula, you might have a 7 minus a -4, double negative, and you'll have -4 squared, and some students will say that's -16 because they forget that when you square a negative, it's always a positive. There's just so many opportunities for mistakes with the distance formula. Why not turn this into a right triangle and say, okay, why don't we just use Pythagorean Theorem? Just count. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. They both have a length of 6. So to find the distance, I'm going to say a squared plus b squared equals c squared, or distance squared. Okay, 36 plus 36 is 72. So have diameter equals 72. Okay, I don't want diameter squared, I want diameter, so I got to take the square root of that. So my diameter is equal to the square root of 72. See how much quicker that is in the distance formula? I mean, I can do this in my head. When you're trying to find the hypotenuse of a right triangle, all you do is square one leg, add them together, and take the square root. 6 squared plus 6 squared is 72. Take the square root of 72. You're done. Square root of 72. And you're still over there writing in the numbers into the distance formula. Okay, and we're already done over here. All right, so why not use the easier path? If you want to do the distance formula, knock yourself out. Here's the distance formula. x2 minus x1 squared plus y2 minus y1 squared and Plug in your values and calculate. You'll get the same exact thing. You'll also get the square root of 72. But that's the diameter. I don't want the diameter. I want the radius. So the radius is going to be the diameter, what? Divided by 2. Okay? But then for our equation, we want r squared. Okay? So now I got to square this number. So r squared is going to be the square root of 72 over 2, and then I got to square that whole thing. Now when I square the top, the square root of 72 squared is just itself, 72. And when I square the bottom, 2 squared is 4. 72 divided by 4 actually becomes 18. Okay, so 18 is my r squared value. All right, now I still need the center though. How do I find the center? Well, that's where we're going to use our midpoint formula. So the center, I'll put in parentheses, midpoint. That equation is going to be x1 plus x2 over 2 comma y1 plus y2 over 2. All right, so it's just the average of the x's. I'm going to add the two x's together, and I'm going to divide by 2. I'm going to add the two y's together. I'm going to divide by 2. So the center is going to be the 2 minus the 4. Add the two x's, divide by 2, and then add the two y's. 2 minus 4 is negative 2. Negative 2 over 2 is negative 1. 7 plus 1 is 8. 8 over 2 is 4. So my center is negative 1, 4. Okay, so now I've got the center and I have the radius. Now I'm ready to plug it into my equation up here. All right, x minus h, so remember we've got to flip that sign, so that's going to be plus 1 squared plus y minus k, we got to flip that sign, y minus 4 squared equals r squared, and we already calculated that. R squared is 18. That's going to be equal to 18. Okay. If I wanted to draw a sketch of this, again, we don't have to, but if you wanted to draw a sketch, then you could go to your center, negative 1, 4, and then you could sketch a circle here if you wanted to, but you don't have to on those. Okay, number 7. A parabola with vertex at 2, negative 6 that opens up. Okay, so if the parabola opens up, does that mean we have a reflection? No, because a reflection means the parabola opens down. So I already know my equation is y equals a times x minus h squared plus k for my parabola, for my quadratic. Okay, so I know now that I don't have a reflection, so there's no negative here. What am I my a value? Well, they didn't tell us anything. They didn't tell us whether it was a stretch or compression, so we don't have an a value either. So now I have x minus h, so I'll just flip that sign. X minus 2 squared plus my k, which is negative 6. Okay, so there's my equation. Now, what if they had said the parabola opens down and there's a vertical stretch of, say, 3? Okay, then my equation would be y equals, if it opens down, that means there's a reflection, and if it's a stretch, that means my a is 3. And then it would be x minus 2 squared minus 6. Okay, so they're giving us the different transformations here. Okay, but this one doesn't have that, so in this case, this is our answer. Right? So just know that, just in case, hint, hint, just in case you see something like this on the test on Friday. All right, so I'm not gonna sketch this one because it says you might want to draw a sketch just for sake of time for the video. I'm just going to go ahead and skip on. All right, number 8 says prove whether or not this is a scalene acute triangle. So we got 3 vertices. Let's go ahead and plot those first. 2, 0, 2, 3, and 6, 4. All right, there's my A, there's my B, and there's my C. Let me find my ruler here. I would definitely encourage you guys to use rulers and straight edges on this test, just so the more accurate, more attention you pay to detail, the less likely you are to make a mistake, especially when you're trying to find slope and distance and all that stuff. If your lines are crooked, that's going to mess you up. Okay, so in this case it's a triangle. I want to know, first of all, let's figure out whether or not it's a scalene triangle. So to do that, I need to know the distances of all 3 sides. If it's scalene, none of the sides match up. Okay, so I need to do either the distance formula 3 times or what? Pythagorean theorem. Okay, now for AB, I don't need either one of those. I can just count. AB is just a vertical line, so I just go 1, 2, 3. That's easy. Thanks, Mr. Bernice. That was easy. All right, for BC, once again, I'm going to make a right triangle out of this. This will be kind of small, but there is a right triangle right there. That side has a length of 1, and this side has a length of 1, 2, 3, 4. Okay, so how do I find the hypotenuse? I do 1 squared plus 4 squared and take the square root. 1 squared is 1, 4 squared is 16, 1 plus 16 is 17. Take the square root, so the square root is 17. I mean, I can just do that so fast in my head. Okay, and while you're still over there messing with the distance formula. But let's write it out. 1 side squared, a squared plus b squared equals c squared. 1 plus 16 equals c squared. So 17 equals c squared. Take the square root. And in this case, we're actually finding the length of BC. So I guess technically I should say BC. So BC is the square root of 17. Okay, so AB is 3. BC is 17. All right, now I need to find AC. Right triangle. 1, 2, 3, 4. 1, 2, 3, 4. Watch this. 4 squared is 16. 4 squared is 16. 16 plus 16 is 32. Take the square root, so it's the square root of 32. Done. All right, let's write it out though. 4 squared plus 4 squared equals AC squared. 16 plus 16 equals AC squared. 16 plus 16 is 32 equals AC squared. Take the square root, and AC equals the square root of 32. Okay, so guess what? 3 square root of 17, square root of 32. So yes, yes, check. Yes, it is scalene. But then it asks whether or not it's an acute triangle. Okay, so to do that, you guys have already learned how to do this, whether you remember it or not, but we did cover this in one of our previous chapters, and to figure out whether or not it's acute, obtuse, or right, we did this in chapter 7, you simply compare a squared to b squared, a squared plus b squared, and compare it to c squared. If a squared plus b squared equals c squared, then it's of course a right triangle. That's Pythagorean theorem. If c squared is bigger, remember, if c squared is bigger, let me do this with pens. Here's a right triangle. If c squared is bigger, then the hypotenuse has to open up. C squared is bigger. That's going to open up that triangle. That's going to make that an obtuse triangle. Okay. If c squared is smaller than a squared plus b squared, then the hypotenuse is shorter, and that becomes an acute triangle. So what I need to do is I need to compare a squared plus b squared, compare that question mark, compare it to c squared. All right, my a is 3. All right, so 3. All right, by the way, how do I know which one c squared is? It's the bigger one. Okay, 3 square root of 17, square root of 32, that's the biggest one. Okay, so 3 squared, my middle one will be plus the square root of 17 squared, and we're going to compare that question mark to c squared, the square root of 32 squared. 3 squared is 9. The square root of 17 squared is just 17, question mark. Square root of 32 squared is 32. And 26 is less than 32. Okay, so when c squared is bigger, that triangle's got to open. It's got to open up, make room for that wide obtuse angle. All right, so this is actually going to be an obtuse triangle. So the answer is no, it's not an acute triangle, although it is a scalene triangle. Okay, moving on to number 9 here. Prove that this is or is not a rhombus. So A is 2, 0, B is -5, -1, C is 1, down 7, and right 7, down 2. All right, so this was A, nope, check that, A, B, C, and D. What have I been telling you guys all year long to do with your eyeballs? Throw them in the trash can. You cannot go based on what your eyeballs say something is or is not. Does that look like a rhombus? No, of course not. Of course it doesn't look like a rhombus. So of course it's not a rhombus. So if you write down on the test, no, this is not a rhombus because it doesn't look like a rhombus, then I will make you sit on a cactus. Okay? That's my promise to you. I will make you sit on a cactus. Yes, it doesn't look like a rhombus. Doesn't matter. We have to what? Prove that it is not a rhombus. Okay? If you're trying to prove somebody is innocent or guilty in a court of law, you can't just say, yeah, they're guilty. Look at them. Look at them. Just look at them. Of course they're guilty. No. You got to prove the evidence. Okay? All right, so what do I know about a rhombus? All four sides are the same. So check this out. All I really need to do is show that two of the sides are not the same. Okay, so let's look at BC and CD. I'm going to make a right triangle out of these to find the distance. If you want to use the distance formula, knock yourself out. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Okay, so that's easy. I have the same thing going on again. A squared plus B squared equals BC squared. 36 plus 36 equals BC squared. 72 equals BC squared. Take the square root. BC is the square root of 72. So if any other leg is not the square root of 72, then it's not going to be a rhombus. Okay, so let's look at this one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So I can already tell you right there. If this right triangle was 6 by 6 and this was 5 by 6, then of course the hypotenuse can't be the same length. But we still got to show it. 5 squared plus 6 squared equals CD squared. 5 squared is 25. 6 squared is 36. 25 plus 36 is 50, 61. And so CD is the square root of 61. Okay, so no. I would say it is not a rhombus because all four sides are not the same. And that's really all you need to do for that one. Okay, moving on to the last page. Okay, number 10. Oh, this is a gimme problem. Put this one on here on purpose because I wanted you guys to have an easy gimme problem. All right, so prove that 5, -4 is or is not a point on the circle. All you got to do, guys, is plug in your x right there, plug in your y right there, and see if it equals 130. So we got 5 minus 2 squared plus -4 minus 7 squared. Is that equal 130? I'll put a little question mark right there. 5 minus 2 is 3. -4 minus 7 is -11 squared. 130. 3 squared is 9. Now again, here we go. I see this all the time. I see students writing down 11 squared is 121. I see students writing down -11 squared equals -121. Okay. One reason why they're doing that is because they're typing it in on the calculator. Okay, which is really kind of lazy when you're just squaring 11. They're doing this, -11 squared. Yeah, of course it's -121 because your calculator's doing the order of operations. Okay, it's doing, please excuse my dear Aunt Sally, they're doing the exponents first. They're squaring the 100, they're squaring the 11 and getting 121, and then they're making it the addition and subtraction, then they're making it 11. If you put that guy in parentheses, then you're also squaring the negative. And of course, we know common sense, when you square any number, it's always going to be positive. Okay, so make sure you don't fall into that trap. -11 squared is plus 121. Does that equal 130? Why, yes, it does. Okay, so I'll say yes, the point 5, -4 is on the circle. Okay, number 11, perform the indicated algebraic transformation, graph the original and the image. Some of you guys on the quiz were not graphing stuff and you weren't labeling stuff. You can't just graph two images. You got to give me the A and the A prime, the B and the B prime, etc. All right, so what are we doing here? We're going from x, y, and we're adding 2 to the x, and we're subtracting 1 from the y. So this is a translation. We are going right 2, and then we're going down 1. Okay, All right, so I'm going to just simply add 2 to all these x's. So that's going to be 2, 0, 3, 7. I just added 2 to all the x's, and then I'm going to subtract 1 from all the y's. 1, 3, 7, 4. Okay, so those are my new points. This would be like A prime, B prime, C prime, D prime. Alright, so now it's time to graph the 2 images. So let's start with our original 0, 2, 0 up 2, then -2 up 4, then 1 up 8, and then right 5 up 5, A, B, C, D. Okay, and let's graph our 4 new coordinates. 2, 1, that's A prime. 0, 3, that's B prime. 3, 7, 3, 7, C prime, and 7, 4, D prime. Okay. All right, and there you have it. What kind of transformation is this? It's a translation because we're moving horizontally and vertically. So I would say this is a translation right 2 down 1. Okay, next one we are reflecting. I know this one had an original typo with A, B, and C. I went ahead and corrected that for the W, X, Y, Z. So we were reflecting across the x-axis. Okay, we are reflecting around the x-axis, this guy right here. Okay, so it's going to be the mirror image on the top side. All right, so for Z prime, I'm on the x-axis. So when I flip Z prime, do I go anywhere? Nope, I stay right there. That will also be Z prime. The Y is 1 away on the bottom, so I'm going to be 1 away on the top. That's going to be Y prime. X is 1 away on the bottom, so I'll always also be 1 away on the top. W is 1, 2, 3, 4, 5 away on the bottom, so 1, 2, 3, 4, 5 away on the top. Now, if you want to remember all these rules, you know, the students love to make transformations more difficult than they really are. You got all these rules: flip this, flip that, change this, swap that. If you just use a bit of common sense, it's really not that hard. If you want to memorize the rule and say, okay, when I flip across the x-axis, that I'm changing the sign of the other coordinate, I'm flipping the sign of the y, then you certainly can remember that. I like to take a little bit more of a common sense approach. So my W prime is going to be 1, 2, 3 up 1, 2, 3, 4, 5. That's -3 up 5. X is left 1, 2, 3, 4, -4 up 1. Y prime is 1, 2, 3, -3 up 1. Z prime is 1, 2 to the left, so that's just -2, 0. Okay, there's our reflection. Home stretch, guys, home stretch. Okay, so graph the final image of the figure after the transformation given and provide the final coordinates. So we are rotating. Okay, we're rotating. Here's where I taught you the common sense rule. You know, if you want to remember all those rules, I gave you the transformation study guide. If you want to remember, swap that, then X changed to negative, this Y changed to negative, flip that, swap that, then knock yourself out. However, what I taught you guys to do was just to take your point, make your rotation, figure out which quadrant you're in, switch the X and Y, and then the quadrant that you're in will determine the signs. But before I do that, I really need to come out here and write down my coordinates for the 4 original points. E is down 0, down 1. F is 1, 2, up 1, 2, 3. G is 1, 2, 3, 4, 5, up 1. and h is 1, 2, 3, down 1, 2, 3, 4. So 3, negative 4. Okay, so that when I'm doing a 90 or 270 degree rotation, the first thing I told you to do with these is what? Flip them. Okay, so I'm going to switch the x and the y. Okay, so this is I'm going to switch, make that 1, 0. Okay, I don't care about the negatives. Don't worry about the signs. Okay, forget about the signs. I just want to switch the x and the y. So f prime becomes 3, 2. G becomes 1, 5. Don't care about the signs. And h becomes 4, 3. We'll figure out what the signs are in just a minute. Okay. All right, so that's really the only thing you have to remember about rotations is just make sure you switch the x and the y. All right, if it's 90 degrees counter, here's my clock. Counter, we're going against the clock. So we are taking the doorknob and we're turning it to the left. Okay, so each one of these points is going to go one quadrant to the left. So that means this guy is going over here, turn to the left. This guy is going over here, turn to the left. This guy is actually going up into the first quadrant. This guy, since it's actually on the axis, I'm still going to the left, but it's just going to go right here to the next axis. Okay, here's quadrant 1, here's quadrant 2, here's quadrant 3, here's quadrant 4. All right, so then all I got to do is figure out which quadrant I'm in, and that determines what my signs need to be. Everything in the first quadrant is what? Positive, positive. Everything in the second quadrant is negative, positive. Everything in the third quadrant is negative, negative. And everything in the fourth quadrant is positive, negative. Okay, so we said F and G, both of these guys, I'm turning to the left. They're going to go to the next quadrant to the left, and everything in quadrant 2 is positive, negative. So in E and F, everything in quadrant 2 is negative, positive. So E and F are both negative, positive. Bam, done. G, oh, you know what? I'm sorry, guys. Oops, sorry. I did F and G first. Sorry. Okay, F and G are in the first quadrant. Both of these guys are going to the second quadrant. So both F and G are in quadrant 2, which are negative, positive. So both of those are negative x, positive y. This guy E that's on the axis, when I flip him, he's just going to be sitting right here. He's going to be sitting at 1, 0. Okay? You don't have a sign for the y value there. And then this guy H, when I rotate it one click, one quadrant to the left, he's actually going up in the first quadrant where everything is positive, positive. So we just leave that alone. Okay, so see how easy that is? Switch the x and y, make your turn, do your rotation, figure out which quadrant it's in, and then that will tell you what all the signs need to be. So you don't have to memorize a bunch of formulas. Okay, and here we go. Last one here, guys. Determine what kind of function is represented by the following table and provide the equation from the table. Okay, so here's where we have to use what we learned on the day where we compared graphs. We got to use our first and second differences to figure out whether or not it's linear, quadratic, exponential. I know it's pronounced linear. Mr. Renee says linear. The first 4 letters of linear are line. So I say linear. Your brain is forced to think, oh, this is a line. Okay. So let's look at our first differences. I'll put first over here. First differences are, how do I get from 11 to 5? Minus 6. How do I get from 5 to 3? Minus 2. How do I get from 3 to 5? Plus 2. 5 to 11? Plus 6. 11 to 21? Plus 10. So the first differences are not the same. Okay, so it can't be linear because the first differences would be the same. Now let's check out the second differences. How do I get from negative 6 to 2? Add 4. How do I get from negative 2 to 2? Add 4. How do I get from 2 to 6? Add 4. 6 to 10? Add 4. Okay, so if all of my second differences are the same, I am in quadratic land. Okay, how do I know if I'm in exponential land? I would have a common multiple. Okay, I'm multiplying by 2 every time. My y's are doubling, or my y's are being cut in half, or what have you. All right, but now we've got to figure out what is the equation from the table. Okay, so now how to do that? The normal, since I'm in quadratic land, my equation is y equals a times x minus h squared plus k. So the first thing I need to do is I need to find this guy here. I need to find A. You guys might not remember this, but you did this exact same thing when we did our catapult project the first 9 weeks. Okay, you put in, you and your group plugged in all your marshmallow height and distance data, and you calculated what this A value was. And we're going to do the same thing here. So where do I get the X and the Y and the H and the K? Where do I get all that stuff from? Well, let's first figure out what our vertex is. Okay, now remember, everything happens at the vertex of a parabola. Okay, your line of symmetry, that's where the mirror image starts and stops. So I'm simply looking for my Y value that's sandwiched in between two of the same numbers on the left and the right. This tree is the tree. Yeah, this huge tree. This 3 is between 5 and 5. Okay, so that means this guy is this line of symmetry point, the axis of symmetry. So that is my vertex. So I would encourage you guys to just somewhere over here, just write it down. Your vertex is 0, 3. That is your H and your K. All right, so now that's what I'm going to plug in for my H and my K. Now, how do I get my X and my Y? I choose any of these points, guys. Choose any of them that aren't the vertex. Okay, pick any other point that's on the parabola. I'm going to choose 1 and 5. They seem like easy numbers to work with. Choose the point that's the easiest to work with. All right, so I've chosen 1 and 5. All right, so my point is 1, 5. That will be my X and my Y. My X and my Y. Okay, so I have my H, check. I have my K, check. I have my X, check. I have my Y, check. So I just plug these 4 points in, and all I'll be left with is the A value that I can calculate. Okay, my Y is 5. 5 equals A, that's what I'm trying to find, equals X. Where's my X? There's my X, 1. H, where's my H? H is 0, so it's 1 minus 0 squared, plus K. Where's my K? There's my K, plus 3. All right, so 5 equals A times 1 minus 0 squared is just 1. 1 squared is 1. A times 1 is just A. So I have 5 equals A plus 3. Subtract 3 from both sides, and A is equal to 2. Okay, so now I have my A value. Check. Now I'm ready to plug it into my formula for my quadratic. All right, so my formula, here again, here's my formula. So I leave the X and the Y alone. Those will always be in any quadratic formula. Just like when you plug stuff into a calculator, when you go to Y equals, you're always going to have a, oops, I can't see that. You're always going to have a Y and an X. Okay, so that doesn't change. So I'm going to have Y equals, but now I have an A value. I just calculated. My A is 2 times X, leave the X alone. All right, now I'm going to re-plug back in my vertex again. Minus H, where's my H? There's my H. X minus 0 squared plus my K plus my 3. And I don't need to leave this as 0. X minus 0 squared is just x squared, so this simplifies to y equals 2x squared plus 3. And that is how you find the equation of a quadratic based on the data in the table. And you will definitely be guaranteed, guys, on Friday to have one of these charts where the second differences will be the same. It'll be a quadratic, and you will have to come up with this equation. Okay, you may have another one where it might be linear or exponential, but you'll definitely have one of these with a quadratic. All right, guys, that's it for this test review. This video right now is 48 minutes long. Okay, so I basically just worked through the test for you, and that was 48 minutes long. Now, I'm the math teacher, so of course I know how to do this stuff a little bit faster. And of course I was taking time to explain all this stuff, but you can see this is a long video, so you're definitely going to be stretched and pressed for time if you're not 100% sure how to do every single one of these when you walk in that door. So I'm begging you, please study hard, come in to see me for tutoring, watch this video as many times as you need, look at the posted solutions on my website. Don't just do the test review and call it quits. Study it. When you finish, study it for another 30 minutes. Check your answers online. Say, yep, I got this. Yep, man, I feel comfortable with this. I know exactly what to do here. On the ones you're not comfortable with, just study it until it sinks in and you got it. All right. So I hope you guys enjoyed this video, and I wish you the best of luck on the test, and we will see you on the next video.